For billions of years, the moon's south pole has guarded a secret that could change the future of human civilization. Deep inside craters so vast and so steep that sunlight has never touched their floors, scientists believe something extraordinary is hiding. Ancient, untouched water ice, frozen in total darkness since the birth of the solar system. If this ice truly exists in the quantities scientists suspect, then it may be the most valuable resource humanity has ever discovered in space. It is not just water. It is air. It is rocket fuel. It is agriculture. It is radiation shielding. It is the foundation of an entire off-world economy. NASA wants it. China wants it. SpaceX wants it. And every agency on Earth understands one truth. Whoever reaches this ice first will control the future of the moon. Yet, the South Pole is one of the most dangerous environments ever targeted by a space mission. Temperatures in the permanently shadowed regions plunge below minus 230 degrees Celsius, cold enough to freeze air, cold enough to destroy most electronics instantly, cold enough that sunlight has not illuminated these regions for over 2 billion years. They are ancient, preserved, and unknown. No rover has survived there. No astronaut has approached. Satellites can only guess at their contents. For decades, scientists have looked into the darkness and wondered what secrets lie inside. In 2026, China will answer that question. The mission is called Chang'e 7, and it is unlike any lunar mission humanity has ever attempted. It does not rely on wheels or tracks. It does not avoid danger. It seeks it. And at the center of this mission is a robotic explorer, so unusual, so surprising, and so bold in design that it may completely rewrite how we explore other worlds. A tiny machine that does not roll or drive. It hops straight into the darkness. But the real story is bigger than a robot. It is about why China is racing toward the moon faster than any nation since the Apollo era. It is about what NASA is quietly worried about. It is about why space agencies around the world are watching 2026 with unease. And it is about how one mission might determine who leads humanity into the next century of spaceflight. To understand why Chang'e 7 is so important, you need to understand what makes the moon's south pole different from every other place humanity has explored. Unlike the equatorial regions visited during the Apollo missions, the South Pole contains a mixture of eternal sunlight and eternal darkness. Mountain peaks near the pole receive constant illumination, making them ideal for solar power. But just a few kilometers away, deep craters never see sunlight at all. These permanently shadowed regions are colder than any known location in the solar system, except the surface of Triton. They are so cold that molecules hitting the ground freeze instantly. Over billions of years, comets, asteroids, and solar winds have deposited hydrogen, oxygen, and volatile materials in these craters. And because the temperatures never rise above freezing, the ice never melts. It accumulates, layer after layer, century after century, until the moon becomes a vault of frozen history. NASA's Lunar Reconnaissance Orbiter detected these ice deposits indirectly through neutron measurements. India's Chandrayaan missions confirmed signatures near the poles, but none of these spacecraft have physically entered the dark regions. No one has ever taken a close look at the ice. No one knows how thick it is, how pure it is, or how difficult it would be to mine. And because no sunlight reaches these craters, solar-powered rovers cannot explore them. Batteries freeze. Equipment stops. Cameras fail. So China asked a question no one else dared to. What if, instead of driving into the darkness, you simply jump into it? Chang'e 7 is not a single spacecraft. It is a coordinated system, an orbiter to map the surface from above, a relay satellite to maintain communications, a lander to carry the primary instruments, a rover to explore the terrain around the landing site, and the most daring element of all, the small, autonomous, hopping robot designed to leap directly into the pitch-black crater floors. This robot is a triumph of engineering minimalism. Because it must survive extreme cold, it relies on low-power systems, compact sensors, and a cold gas thruster that can provide tiny bursts of upward force. Lunar gravity is so weak, just 1/6 of Earth's, that a short burst of cold gas is enough to send the hopper tens or even hundreds of meters across the surface. It can hop down steep slopes, into shadowed regions, and onto crater floors that no rover could ever reach. Then, after completing its measurements, it can hop back out again. This ability fundamentally changes what we can study on the moon. China's hopper will measure temperature, surface chemistry, volatiles, and mineral content. It will scan for crystalline ice structures. It will analyze gases trapped in the regolith. It will survey the thermal environment. It will sample the very substance NASA's Artemis program depends on, polar ice. And here's where things get interesting. China is not just exploring for science. They have a broader plan, one acknowledged openly by the China National Space Administration. Their long-term goal is to create a permanent human presence on the moon. Their plan has 3 major milestones: a robotic demonstration in the 2020s, a crewed lunar landing before 2030, and the construction of a multinational lunar base, the International Lunar Research Station, by the mid-2030s. To build a base, humanity needs water. Not a little water, a lot. Water for drinking, water for oxygen, and water for rocket fuel. Conventional chemical rockets require enormous quantities of propellant. Launching fuel from Earth is staggeringly expensive, but if you can produce it on the moon, you turn the lunar surface into a refueling station for the entire solar system. NASA knows this. SpaceX knows this. China knows this. But NASA's own mission to explore these craters, the VIPER rover, was canceled because of budget pressures and landing site uncertainties. That leaves China as the only nation planning to physically enter the dark regions before 2030. If Chang'e 7 finds large, easily accessible deposits of ice, China will have the first definitive map of where lunar infrastructure should be built. And if they build the first base, they will set the rules. Rules about landing zones, resource extraction, safety corridors, and international cooperation. This is why NASA officials, without saying it directly, are concerned about the timing. Artemis 3, the first crewed landing of the Artemis program, is facing delays. Starship, the spacecraft required for the lunar landing, is still in testing. Meanwhile, China's lunar lander and next-generation Long March rockets are nearing final development. There is a scenario, not impossible, where China lands astronauts on the moon before NASA returns humans there. In that timeline, Chang'e 7 becomes the mission that proves the feasibility of long-term habitation. It becomes the mission that identifies the best landing sites. It becomes the mission that shifts global momentum. But the scientific stakes are even higher. The ice at the lunar South Pole may hold information older than Earth itself. Some of the molecules trapped in the crater floors predate the formation of the planet. They may include hydrogen atoms from ancient comets, oxygen delivered by solar winds, and organics from asteroid impacts. These compounds, preserved in eternal darkness, could answer questions about the formation of Earth's oceans, the migration of water through the early solar system, and possibly how the ingredients of life arrived on our planet. Imagine the hopper entering the darkness, landing on a frost-covered surface, and sampling material that has not changed since before humans existed. Imagine it detecting pure ice crystals glinting under its infrared sensors. Imagine it reporting high concentrations of trapped hydrogen, proof of ancient cometary deposits. Imagine it discovering layers of ice meters thick. These findings would electrify the scientific community. They would radically accelerate humanity's plans for lunar settlement. They would provide the first clear evidence that the moon could support large-scale habitation and become a fueling point for deeper exploration. But the opposite is also possible. The hopper could find the ice thin, scattered, or mixed with so much regolith that extraction becomes extremely difficult. That scenario would force NASA and China alike to rethink their base plans. It could shift attention to alternative sites, or push for nuclear-powered extraction systems. Whatever the outcome, Chang'e 7 will provide answers that no satellite could ever deliver. And there is yet another twist. The Chang'e 7 orbiter will carry instruments to search for traces of lunar volatiles, exosphere particles, and residual gases that might originate from deeper lunar geological processes. Some scientists suspect that there may be transient plumes, gas releases, or chemical interactions occurring near the poles. If China detects these subtle signals, it could fundamentally alter our understanding of lunar geology. The Chang'e 7 mission also sets the stage for Chang'e 8, launching around 2028. That mission will test 3D printing techniques using lunar soil, in situ resource utilization equipment, and prototype construction technologies for China's future moon base. In other words, Chang'e 7 finds the resources, and Chang'e 8 begins using them. Together, they form the backbone of China's lunar strategy. And this raises a question scientists are now quietly discussing. What happens if China reaches the moon's south pole, confirms large ice deposits, and begins building infrastructure before any other nation? The answer could define the next century of human exploration. A nation that controls the first lunar base will control access to resources, control navigation protocols, and control the development of lunar industries. Mining, energy production, manufacturing, science experiments, and deep space mission assembly, all of it could originate from the moon. This is why 2026 is one of the most important years in the history of space exploration. Not because of a rocket launch, not because of a human mission, but because of a small, hopping robot that will go where nothing else has gone before. Picture it, a silent, cold crater floor. Darkness so complete that even starlight cannot reach it. Temperatures colder than anything on Mars, colder than anything on Earth, colder than any human-built machine has ever explored. And then a faint metallic sound. A small robot landing in the shadows, its sensors glowing gently, its instruments warming up, its camera adjusting. And for the first time in human history, humanity sees what lies inside the darkness. Every nation will be watching. Every space agency will be calculating the implications. Every scientist will be analyzing the data. And every engineer will be thinking, what can we build with this information? Because Chang'e 7 is more than a scientific mission. It is the opening chapter in a new space race, one that will not be won by planting flags, but by building infrastructure. One that will not be decided by speeches, but by resource maps. One that will not be about who gets to the moon first, but who knows it best. If Chang'e 7 succeeds, if it finds thick ice, extractable ice, ice that can sustain life and fuel rockets, then everything changes. The moon becomes not just a destination, but a stepping stone, a logistical hub, a launch point for Mars missions, a research station, a mining site, a home. And if China is the first to prove that this dream is possible, then the world will be playing catch-up for decades. This is Chang'e 7, the mission that may decide who leads humanity's next great era, and the world is not ready for what it might discover.